Good morning, students. Today, we are going to learn on continuation of synchronous motors. So, what we have seen in previous classes. Last class we have seen that what is AC motor, classification of AC motors, comparison of synchronous and asynchronous motors, just like synchronous motor and asynchronous motors, advantages and disadvantages of synchronous motors, and applications of synchronous motors. Now, in this class, our main objectives are: what is rotating magnetic field, how it is produced, generation of three-phase rotating magnetic field in synchronous motor, and it can be proved with mathematical proof of production of rotating magnetic flux. Now, as we know that in previous classes we have seen, so one of the very interesting machine, unlike DC machines, induction motors, the synchronous motor is a specialized motor, whereas DC motors, it requires only DC supply to the rotor through slip rings or commutator. Whereas in case of three-phase induction motor, it required three-phase AC supply to the stator itself. In DC motors, it has the DC supply required for the poles which are on stator side, armature in rotor side, but we require to give the DC supply to rotor as well as the stator. Whereas in case of induction motor, we are going to give three-phase AC supply to the stator itself, and rotor side, whether you are going to use short circuited bars just like squirrel cage rotor or slip ring rotor, where there is a winding on rotor side, but there is no external supply given to rotor in case of three-phase induction motor, then it will works. Whereas in case of synchronous motor, we required now the combination of DC motor and AC motor, then we are going to get a synchronous motor, just like, because as we have seen previously the construction of synchronous motor, where it has a stator owned with three-phase distributed winding. At the same time, rotor also has a concentrated winding. Now, when three-phase AC supply given to stator and plus minus DC supply given to the rotor, stator establishes its own magnetic field, but due to three-phase supply, R phase, Y phase, B phase, with the frequency 50 Hz and 120 degrees apart from phase to phase, the current flowing through winding at a different instance, its value changes. So that means it induced a magnetic flux of 1.5 times of each phase produced by its own winding. That means the resultant flux which is produced when three-phase supply is given to in stator, and that is a 1.5 times of maximum flux produced, and this flux, resultant flux, not in stationary, it being rotated in a air gap, just like physical poles rotating. The induced resultant flux rotating in the air gap at a synchronous speed nearly. That is equal, what is the synchronous speed? Ns is equal to 120 F by P. Here 120 is a constant, F is a supply frequency, that is equal to 50 Hz or 50 cycles per second, and P is the number of poles at the time of design itself, whether 2 poles, 4 poles, 6 poles, so on. Let us assume P is equal to 4 pole machine. Then what is the synchronous speed? So that is equal to Ns is equal to 120 F by P. 120 into F is equal to 50 divided by P is equal to 4. Then we are going to get nearly the 1500 RPM. So 1500 RPM rotating magnetic field rotating in air gap due to three-phase supply to the stator. Now, when DC supply is given to the rotor, it produced its own magnetic field, but this magnetic field is a stationary because it's a concentrated winding. Then what is happening? So this magnetic field of rotor and stator magnetic field, there is a interaction between two magnetic fields. As you know basics, whenever two similar poles come together, there is a force of repulsion. When opposite poles come together, then there is a attraction. Now in this case also same things happened. So this already we learned with help of diagrams. Now even three-phase supply is given to the stator and DC supply is given to the rotor, but motor will not start initially. It is not a self-starting motor. Even two types of the energy is given to the machine, but it is not a self-starting motor. That purpose we require the another arrangements at initially by using the external prime mover. External motor has to be coupled to our rotor. Then that motor, by using that motor, our rotor is rotated at a near to the synchronous speed. Then DC supply is excited to the rotor. This field, rotor field and the stator field is magnetically coupled. Once it is magnetically coupled, then no need of this external motor mechanical input. Then you can remove it. Even then the motor is continuously run as a motor, the stator and the rotor magnetically coupled. This is a one method we have seen. And another method is the, so if there is no possible to provide the mechanical motor at initially, because it is a costly also, and after running at a synchronous speed we have to decoupled to this motor. Otherwise what will happen, it is connected to the same shaft, it acts as a load on our synchronous motor, hence this is something problem. Hence how to overcome this one? By using the damper winding. Damper the copper strips inserted in rotor pole shoes. The damper winds the winding the copper strips, they inserted in pole shoes, and both sides is a short circuited, just like the squirrel cage rotor uh, strips. Then what is happened? While only AC supply is given to the three-phase motor, it produces a magnetic field and it is rotating in the synchronous speed. This stationary rotor cuts this rotating magnetic field. As per Faraday's laws of electromagnetic induction, automatically it induces the EMF in the rotor damper bars. The rotor bars are closed one due to both ends are short circuited, and due to the induced EMF in the rotor damper winding, the currents flows. Whenever the current flowing through the damper winding, it tries to produce its own magnetic field. And this magnetic field and stator magnetic field, there is an interaction takes place. Now, what will happen? So, this rotor field try to catch its main magnetic field, that is a stationary magnetic field. But stationary magnetic field is rotating. This magnetic field try to catch its own father, that is a main magnetic field. Then try to it is interlocked and try to catch its in the moves in the direction of stationary magnetic field. Once is a rotating synchronous speed by the father, that is a main magnetic field, and this kid, that is a rotor field, is try to catch its father. Then automatically it works as a three-phase induction motor. Once it try to move nearby synchronous speed, then what is happened? Now DC supply is given to our rotor. Then permanent magnetic field established on the rotor with help of the external DC supply given to the rotor with the help of the slip rings. Then so now it is running near to the synchronous speed. Then stator magnetic field, rotor magnetic field is coupled each other. Once rotor try to rotate in the same speed of stator magnetic field, then the relative motion between the rotor damper bars and stator magnetic field is zero. At the same time, based on Faraday's laws of electromagnetic induction, the relative motion between the stator magnetic field and rotor damper windings is zero. Then d phi by dt is equal to 0. Then there is no induced EMF in the damper windings. No flux is developed. Then simply it is a conductors, only copper wires. During this period, our main rotor magnetic field and stator magnetic field they linked each other, magnetically coupled, and rotor try to rotate in the same direction of stator field. Now rotor is under running condition. Now it is ready to take any type of the load on rotor. These are the principle of operation of synchronous motor we discussed in previous class. Now today our aim is to how this rotating magnetic field generated in the air gap. When three-phase supply at 50 Hz is given, what is a phenomenon takes place inside and how this rotating magnetic field 1.5 times of 5m is produced and how it will rotates from one angle to the 360 degrees rotates. We have to clarify this analysis with the help of our well-known phasor diagram as well as vector diagrams. These two diagrams will tell us the very clarity how this field is generated and constant at every degree, every angle, and how it's moves from some angle 0 degrees to 30 degrees, 60 degrees, 80 degrees, different degree angles. So we will see also mathematical values. Very interesting, very easy also. Just you observe how the vectors changes, how the phasors changes during at different angles. So now before that one, let us see. So generation of three-phase rotating magnetic flux. When a three-phase distributed winding displaced by 120 degrees mechanical angle is excited by three-phase balanced supply at 50 Hz frequency, then it produces a resultant magnetic flux and rotating in spaces as if actual magnetic poles were being rotated mechanically. So already we discussed this thing. How it is possible? How it is mechanically? So it seems like it is rotating in mechanically in air gap. That is we are going to learn now. So let us see, in this case only we taken the stator part. The stator has the stator frame, stator core. The core is silicon steel with laminations to reduce the iron losses, that is eddy current losses and hysteresis losses. And inner side there is a slots, it may be open slots, closed slots, semi closed slots. In that we are going to own three-phase winding as per whether it is a lap winding, whether it is a wave winding, whether it is single layer or double layer. So already we know this thing. Now this distributed winding, so you can see here, so at R phase and at a different angles, R phase, B phase, Y phase, you can say RYB distributed. Here each winding, as we know that one is a starting, another is a finishing. So R phase is connected to the R phase supply S1 and it has a two coils nearby this one, and after that B phase connected, B also the starting 120 degrees apart, and next Y phase also connected 120 degrees apart. Now you can see S1 at, for example, a reference value, and starting is connected, and after that so S2, that is the Y is connected. After that S3, that is the starting of S3 is the blue is connected. Now so here after the finishing of this windings is connected to the neutral for analysis purpose. Actually this synchronous motors is connected in delta or star initially. Generally it is connected to the delta. Okay, so it is connected between the R phase, Y phase, Y phase, B phase, B phase and R phase is the line voltages. So here analysis purpose, easy understanding purpose, each phase is separately connected to the phase and neutral. Then how the flux is developed here. So each phase is try to produce its own magnetic field. Now so you can see R phase is connected one phase, Y phase is connected to another phase, and B phase is connected to another phase, and this all finishing ends is connected to the common neutral. Then so what will happen? So each has its own winding, but it is distributed in a stator. So for analysis purpose, this is a given figure. Now you can see the how this whenever the this power is given, input given to the this rotor winding, R phase will draw the current from the supply. Now what is happened? So this winding has its own impedance, resistance and inductance. Last class we have seen. So that is a ZA is equal to RA plus J of XL. Due to this ohmic value, and it will draw the current from the supply, then the voltage by this ohmic value, we are going to get that the armature current in each phase. Similarly, R phase draws the armature current, Y phase draws the armature current, and B phase also draw the armature currents. As we know that whenever the current passing through the winding, it establishes its magnetic field. This magnetic field directly proportional to the its initial value, that is the current. As we know that MMF is equal to N into I. N is the number of turns, I is the current. If number of turns increases, then automatically flux increases. If current increases, automatically magnetic field increases. But initially we designed some number of turns. Now what is the variable here? So here variable is the only current. If current draws more current, it establishes the more flux. Now let us assume 3 R phase, Y phase, B phase currents drawing, and these currents are due to the inductance property, it lags with its phase voltages. So R phase has its flux lagged by reference to the voltage, that is the R phase voltage, and correspondingly lagging current is the R phase current. Y phase voltage lagged by the Y current, and B phase voltage, that is current is lagged by some angle because it is the inductive nature. So here there is a power factor between the voltage and current. Okay, that is the basic simple things you should know. Now, so based on this current, now let us, the current produces the magnetic field. Now let us take this magnetic field wave diagram and vector diagram. Okay, so how this vector, the flux wave diagram comes? So due to the voltage, current is flowing. Due to the current, it establishes the magnetic field. This magnetic field follows the current. This current is lagged by the a corresponding voltage phase. Now, so let us draw the magnetic field produced in the stator while from 0 degrees to 360 degrees. Let us see. Now you can see here this phi is the angle in y axis and theta is angle in x axis. Now let us first you take it R phase. So R phase, you can see starting at theta is equal 0 degrees, and because due to the sinusoidal nature, at reference we taken this is the R phase, then phi r is equal to phi max sin theta. That is a sinusoidal in nature. Now what is happen? So phi r is equal to phi max sin theta. So based on this one, it is increasing from 0 degrees to and go on increasing at 60 degrees. That's really at angle of 0.886 percentage and increased further up to 1 value, that is 100 percentage at 90 degrees. Now after that it is go on decreasing towards the 180 degrees. Once again the direction changes and is go on increasing up to 270 maximum and go on decreasing 360. So this sinusoidal changes the flux. Current changes, similarly the flux also move in the same direction. Now after 120 degrees, then Y phase also starting increasing similar to the R phase. After 120 degrees, that is the 240 degrees, now B phase increasing. You can see similar manner. And now, as per our knowledge, this is a phi r is a R phase flux produced in the stator, Y phase produced phi Y phase produced flux, and B phase produced flux in the stator. So we represent it in phasor diagrams. Now the phi r value, that is the value is phi max sine theta, and Y phase the phi max sine theta minus 120 degrees, because 120 degrees lagging. Now because R phase we take as the reference, and here B phase taken as a minus 120 degrees. Now phi B we take in the phi max sine theta minus 240 degrees apart. So here you can see what is here. Now we can see here, based on this one, now you can see, so R phase is going this direction, and Y phase is going this direction, and B phase is going this direction. Now here R phase equation, Y phase equation, and B phase equation. Now let us see, we can now generation of three phase rotating magnetic flux in vector position. Phasor diagram we have seen. Now vector diagram, here what is happening is the R phase we taken as a reference, and Y phase taken the clockwise direction, it is this one, and is further taken the B phase taken the clockwise direction. So here what is happened? So here, so we are going to get this one. Here what is happening? So this is the R phase, this is the Y phase, this is the B phase. We take in the clockwise direction. Or so what is the angle? Is a 120 degrees. Here is a, this is a 120 degrees. This is a 120 degrees. Now here to here 120 degrees, and here to here 240 degrees. Or we can say it here to here taken the minus 120 degrees, here to here we taken the minus 240 degrees. So now R phase is taken as a reference for easy analysis purpose. This is a vector diagrams. So in vector diagram, the magnitude is same. Here what is this magnitude is the same, but what is happening? This angle changes. So this is for example, here this one after 120 degrees is coming, and after 240 degrees it is coming. So at a time all are not maximum values. So let us see this one. Now we have seen the phasor diagram and we see the vector diagram. This is the reference values. Keep in your mind. Now do the simple problem. Now so you can see this is a phasor diagram, this is a vector diagram. Now you take the one angle, so you can easy here. So at that instant theta is equal to and 0 degrees at initially, what is the values of R phase, Y phase, and B phase magnetic fields? So as we know that each phase is developed its own magnetic field, but it is rotating in a synchronous speed. While rotating in synchronous speed, what is its resultant value due to this magnetic field at that different angles? That is our aim. At initially at standstill position, at that starting at 0 degrees, then what is the resultant of R phase magnetic field, Y phase magnetic field, and B phase magnetic field? We are going to analysis. Now at 0 degrees, now we can see what is happened. At when theta is equal to 0 degrees, then phi r, the R phase produced in the winding, is equal to flux produced is 0. That means the current flowing through the R phase winding at that instant is 0. Why? Because it is the initially. So you can see the phasor diagram, and we taken the reference at that condition. So 0 degrees. As we know that sine, that is what is the value formula, sinusoidal value, the phi is equal to phi m into sin theta. So sin theta is equal to 0 degrees. Sin of 0 is equal to 0. 0 into something is 0. So the resultant value phi r at that 0 degrees is equal, we are going to get 0 degrees. Now coming to the phi y, the flux produced in the y phase is equal to at 0 degrees. Now, what is the formula? Phi m into theta minus 120 degrees. As previously we mentioned, the phi m sin theta minus 120 degrees here. You can see here. Okay. Now, so here theta is equal to substitute. This is a 120 degrees y phase because it is a, we taken this a minus 120 at that condition. So phi m sin, so theta is equal to 0, 0 minus 120. So what is happening? Minus sin 120 degrees. So minus sin 120 degrees here, what is happening? So 90 plus 30, we are going to write it. What is happening? Cos 30 degrees minus cos 30 degrees. Cos 30 degrees is equal to minus 3 by 2 into phi m. Now that means here you can observe here what is happening. You can see the phasor diagram. At 0 instant, the y phase is at this condition. What is the magnitude? That is the root 3 by 2. That means not maximum value. Here you can see, here. So here not maximum value, not 1. So only 86 percentage at that instant. That is root 3 by 2. That is called 0.86 percentage. At 0 degrees, it is producing a flux of nearly 86 percentage of flux produced with its own flux. Okay. Now coming, but it is a minus root 3 by 2. That is means here vector, the magnitude is not 1 here, not 1, only this much of the produced. But what is happening? Minus, instead of this direction, it is going to the this direction. Okay. So it is going to the this direction. What is the constant value? The root 3 by 2 value. This is the value. Magnitude is the root 3 by 2, angle is this direction. Compared to the 0 degrees, it is instead of minus 120, it is going to the this direction. Okay. So that is a plus 30 degrees angle, this direction. Now this is equal to 0, R phase is 0. Now only this y phase present this direction. Now next, what is that one? So another phase is equal to, so R phase is 0, y phase is equal to root 3 by 2 phi m. Now B phase, let us see what is the B phase. Now B phase also the phi m sin theta minus 240 degrees, because here you know that. So what is this one? This is equal to B phase. So theta is equal to, what is our angle? So 240, 0 degrees. Now 0 minus 240 sin, so minus of, so 240. So 240 can we write what is the value? So we can write it the 180 minus 30 degrees. So minus get cancel. We are going to get the sin, what is the value? Sin 60. So sin 60 we are going to get that is equal root 3 by 2. Simply the sin 60 root 3 by 2 phi m. Now so you can see here, so here this is a value. It is also not maximum 1, but it is also 86 percentage. Now it is a positive direction. That is, if you see the vector diagram, this is not 1 value, it is only 86 percentage value. But is which direction? It is the same direction, not minus. Now previously this is tilted this direction, and now they tilted this direction. This is this direction. Now this is equal 0. This is no value. Now what is happened? So one is previously this is a y phase, this is a B phase. Now we know that this one vector and second vector. So resultant value as per this one vector, we are going to draw it. Then we are going to get the resultant phi r. Okay. So here we are going to draw that figure vector diagram. Now here you can see the phi r is equal to, suppose this is a center. Once again I am explaining, please, because this is the, if understood one this vectors, very easy, dead easy. If you unknown, if you confused in vector diagrams and phasor diagrams, it will take the time to understand. If you understand this one, so very easy to analyze this perfectly. Okay. Now once again I am explaining, please listen carefully. Now at what is happening here, phi r magnitude, how much value? 0. 0 means at center only, r is 0. Now what is the angle? At 0 degrees also angle. 0 magnitude, 0 angle, that means no value, 0 value. At 0, at theta is equal to 0 angle. Now so phi y is this direction, positive y is this direction, but due to the negative minus, so minus means the opposite, this direction, then you write this direction. What is the magnitude? Root 3 by 2. This is the magnitude, root 3 by 2. Now coming to the B phase, what is the value B? B is equal to, now you can take the B, okay, you can take the B, so that is equal to root 3 by 2 magnitude in the positive direction. B is now this is the B direction, this direction only. Now we take the B. What is the magnitude? Magnitude is the root 3 by 2. Now this is this direction, this is the this direction. This is a Y phase, this is the B phase. Now so based on these two vectors, the resultant vector, this angle. So due to this one, we are going to parallelogram and we can write this one and we are going to get this one. So what is the value? So we know that resultant phi r is equal to under root of this whole square and this whole square plus 2 into this into cos of theta. As you know, this is formula. So that is the phi y whole square plus phi b whole square plus 2 into phi y phi b cos theta. By substituting these values, you are going to get resultant phi r. So what is the phi r we are going to get? So we can see. Now this is the phi y and this is a phi b. Now resultant values, so we are going to get it, so that is equal to phi r. The phi r is equal to same formula, as you know that. So the resultant, therefore the resultant flux is equal to phi r into 2 into root 3 by 2 phi m, that is into cos 60 by 2. Then we are going to get what is the value? So that is equal to 1.5 times the field. So because the magnitude is same, otherwise we are going to same formula, root of phi that is a phi y whole square plus phi b whole square plus 2 into phi y phi b cos theta. Now is a cos theta is a both magnitudes are equal, so simple equation phi r is equal to 2 twice of root 3 by 2 phi m into cos 60 by 2. Angle between the two faces is 60 by 2. Then we are going to get 1.5 times of maximum field. That means the resultant field is equal to the flux produced by any one phase into 1.5 times. That is the resultant field. Now what is the resultant magnitude? Now you can see this one. So produced magnetic field magnitude is equal to 1.5 times. It is each phase is producing only 86% now, but it is a 150% flux produced now, resultant value. Now so but what is the angle? Angle is equal to this direction. For example, vertical direction, we take in the reference vertical direction. At 0 degrees, the magnitude is a 1.5 time, but angle is equal to this direction, vertical direction. Okay, let us see another angle. What is happened? You remember this thing. Now coming to the at 60 degrees. So interval of time. What is the value? Now similarly, so we are going to get that So at 60 degrees means this one. At that condition, so we can see this is the Y phase presents, but B phase coming to the 0 value, and R phase slow go on increasing. Now in this case, what is happen? B phase becomes 0 at that instant. Y phase so go on increasing positive direction, but it's a negative way. And whereas the Y phase from 0 to it is increasing to its maximum value. At that instant, at 60 degrees, what is the value? Then phi r also same, we are taking the, this is equal to 60. So what is the formula? The phi maximum, the phi r is equal to phi m sin theta. So theta is equal to 60 degrees. So where sin theta is equal to root 3 by 2. So this is a thing here we are going to take. Now coming to the another phase, you can see it, phi y. So y is coming to the here also y phase, this y phase. So then what is the value? So that is called same. So theta minus the 60 degrees there. So 60 minus 120 degrees we are going to get, so minus root 3 by 2 value. And coming to the another phase, now phi b. The b is, you know that what is the b? B is equal to 0. So that is equal to, we are going to get 0 value. Simple substitute the values. So what we have seen previous formulas, that you should simply apply it. Then we are going to get the values. Substituting the 60 degrees in that value, so we are going to get these values. Okay, so that is equal. Now in this case, the resultant flux is this value. How we are going to get this one? So simply write the vector diagram. Now what is happening? Phi r. Phi r means this direction only. What is the angle? Angle is equal to reference angle. It's a positive value. So same value. Magnitude is equal to only root 3 by 2, this value, same direction. Now coming to the phi y. Y is this direction, but is a minus value. So it is coming to this direction. So write it this one. This magnitude is same, but it is the reverse in this direction. This is the same direction. Now you write in this one, then write the equivalent equation similar to the previous one. This is a phi r. So what is the value? Similarly apply the same formula, that is equal to, so 2 into root 3 by 2 into cos this angle. Now so let us do once again. Now please follow these vectors, and here how we are going to get the 1.5 times of phi m. Simply you take it at similar to the 0 degrees. Here also you are going to draw it. Here phi r. Phi, how we are going to get the root 3 by 2 phi m? Because this is known as the equation. What is the equation? That is equal to phi m sin omega, that is a theta. Omega t is nothing but theta. And phi y, what is the formula? Y, this one we take an equation, that is equal to phi m sin theta minus 120 degrees. Previously we mentioned. Next this one, and we taken as the phi m sin theta minus 240 degrees. Okay, this is a basic formula, sinusoidal equations for these vectors. Now what is the angle now? This is the 60 degrees we are going to apply it. Here 60 degrees and here 60 degrees, here 60 degrees. By substituting these values, we are going to get this value and this value and this value. Okay, simple substitution this equation. So because we know there are sinusoidal equations, in that we are going to apply the substitute the theta angle. Now theta we taken as a 60 degrees. So then we are going to get its magnitude values. At the same time, it also indicates whether it is a positive or negative. Based on these equations, we are going to find the resultant value. Okay. Now, so how we are going to get that one? As we know that phi r is equal to, so here resultant flux is equal to, as we know the vector diagrams, we write it. So here phi r is equal to, how we are going to get? So phi r is a root 3 by 2, that is a 86 that is 0.866 phi m, the positive direction of R phase. R phase this direction, it is the maximum magnitude is a 1, but now we are going to get only 86%. This is the value. Okay. So we take in the which direction? Positive direction, means this direction. Then write the figure. Now we are going to write it in red color. We take it, and this is the one direction, this direction. Okay. Now coming to this one, so y phase. Y phase is equal to same. This is a y phase, this direction. Now, but what is the value? Magnitude is a root 3 by 2, but angle is the minus. We taken the opposite of this one. We take it this direction. So you write it, and you take the another color. Okay, green color we can take, yellow color we can take. So you take it, and yellow color we can take in this direction. Okay. So here B phase, coming to the B phase is equal to 0. So what is the B phase? This direction. Now so magnitude is 0. So magnitude is 0. Now these are the two fluxes exist at that instant. Now as you know that, you draw the vector diagram. So how to draw the vector diagram? So simply draw it vector diagram by another color. We can take it. Okay. Now this vector diagram, this one, and we are going to this one value. Now angle is a 60 degrees. Now based on this one, so you know the formula, this vector diagram. So there is a phi r whole square under root of phi r whole square plus phi y whole square plus 2 into phi r phi y cos theta. Or so previously we have equation that is equal to 2 into this root 3 by 2 phi m into cos theta by 2. Then we are going to get this 1.5 times of field, this one. Okay. So this is a same equation. Okay. 1.5 times of phi m. Okay. So that's what is the formula? So that formula is equal to, as we know that, so this is a phi r whole square plus phi y whole square plus 2 into phi r into phi y into cos theta. This is a formula we know. But the phi r and phi y are the equal magnitudes. So this equation simply you can write it, that is equal to phi r is equal to, okay, phi r is equal to 2 into 1, that is equal to root 3 by 2 phi m and cos theta by 2. Here, so 2 into root 3 by 2 into phi m into cos theta. What is the theta? 60. 60 by 2, 30. Cos 30 is equal to, what is that? Root 3 by 2. Then, so we are going to root 3 by 2, root 3 by 2. So we are going to nearly, that is equal, what is the value? Substitute it, and root 3 by 2 into root 3 by 2. 3 3 is a 3. 2 to cancel. Then we are going to get 1.5 times. That is equal, this is the equation. So phi r is equal 1.5 times of phi m. But what is the angle? So you can see this diagram. Already it has this one. So this two angle resultant phi r. So this is the angle. Previously the magnitude is this direction. Now this is coming this direction now. This direction. So tilted from 0 degrees to this magnitude resultant value tilted. Previously at 0 degrees, this is a magnitude value, and vertical at 60 degrees angle, this is a magnitude, same magnitude, but from this position it changes. So now coming to the another angle, we can take it. Similarly, this is a very easy, and take the another angle at 120 degrees. Where is the 120 degrees? So this is the 120 degrees. At that condition, what is the values? Now y phase became 0 and b phase become negative and y phase still a positive. So by seeing this vector diagram, the phasor diagram you can easily understood. Then or otherwise you simply substitute phi r is equal to phi m sin theta, phi y is equal to phi m sin into theta minus 120 degrees, phi b is equal to phi max sin theta minus 240 degrees. Simply substitute this 120 degrees in place of theta. We are going to get that. So what is the values? So phi r is equal to, still is the positive direction. The whatever. Now, so when this is equal to, so simply, so at 120 degrees, so what has happened here? The phi r is equal, substituting the value, theta is equal to, so phi m sin 120 degrees. Then we are going to get what is the value? So sin 120 degrees, we are going to sin 90 plus theta. Sin 90 plus theta is equal cos 30 degrees. Cos 30 is equal to how much value? So cos 30, that is equal root 3 by 2 value. So that is equal phi r is equal to root 3 by 2 phi m. So please students, but remember that so magnitude is the only 86% always, but direction changes, whether it's a positive direction or negative direction. Okay. Now what is the, now coming to the another phase? What is the phase? B phase. B phase. Now what is the value? So at that 120 degrees, B becomes the negative value. Simply substitute the 120 degrees. What is the phi B is equal to phi m sin theta minus 240. Now substitute the theta is equal to this value 120 degrees, and the 120 minus 240, it becomes a minus 120 degrees. That is equal sin minus sin 30. Sin 30 is the same minus root 3 by 2. Now, so now coming to the y phase. Now in this case, y phase becomes to the 120 degrees becomes 0. So what is the y phase? So phi m sin theta minus 120 degrees. Now theta itself 120. 120 minus 120, that becomes a 0. So simply we are going to get phi y also 0. Then so based on this one, you write the vector diagram. Now r phase is the same direction and b phase is the minus direction. Instead of this direction, we are going to draw this direction. You write this direction. Now resultant value, we are going to this one. Now it is coming phi r. Phi r is equal to 1.5 times of phi m. So you can observe this one. So this is a rotation. First is a vertically. Now if you are observing in a watch, in your clock, so here you will at 12 o'clock, at 2 o'clock, at 4 o'clock. Now it is changing from this direction to this direction, this direction. At this condition, the flux is coming from this position to this position, 4 o'clock. Now if increasing, what is happening? Now it is going this direction. Now it will go in this direction. Now it is going to. That means at that 0 degrees, 60 degrees, 120 degrees, 240 degrees, and 360 degrees. So what is the value? 180 degrees and 300 degrees. Now 360 degrees. So the flux is a maximum here at 0 degrees and 60 degrees is a maximum here, and here we are going to get the 120 degrees and we are going to the 300 degrees and 240. So that means flux is changing this direction. It is a changing. The vector, resultant vector is a changing this direction, this direction, this direction, this direction, changing. Magnitude is same, but the flux is rotating in a one cycle. Same we are going to synthesizing. Okay. Now, so now we take the 180 degrees. So at 180 degrees, what is happening? So at the on 180 degrees, now R phase once again becomes to 0 and B phase B, what is the value? B is equal to, you substitute the value 180 degrees. That is equal to 5m sine 180 minus 240. So, we are going to get that minus 3 by 2 5m. Now, another phase, y phase. So, y phase, now you can see the is a increasing value. So, what is the y phase? 5y 5m sine theta minus 120 degrees. Now, that is equal to 5m sine 180 minus 120 degrees. Then we are going to that, so root 3 by 2, sine 60, that is the root 3 by 2 5m. Now, resultant value. So, we are going to 1.5 times of 5m. Now, vector diagram, you draw the vector diagram. Now, this becomes the r is equal to 0, and now b is equal to, what is happened? So, b is equal to here, y is equal to same direction, and b is still in negative direction. Then resultant value, it becomes to here. Now, what is happened? So, this is comes to the now at 6 o'clock, at 12 o'clock, at 2 o'clock, 4 o'clock and 6 o'clock when changing in this direction. The resultant flux is a 1.5 times in the direction of this direction. Now, coming to the, you take the another angle 240. Similarly, you can do this all calculations. Simple. I think it is a very easy. Now, what is happening? So, we take the based on this minus phi r is equal to, now increased, instead of positive direction it comes to the negative direction. The y phase is still the positive direction. The resultant becomes to the ER. Now, what is happening? It is near to the 8 o'clock. And so, this is the vector. Now, we take the another angle 300 degrees. Similarly, you are going to take these values and you take the another angle. So, 360, then it becomes to the same value. It is coming to the original position. Now, here you can observe what you are observed. So, in this case, here this vectors are only two vectors, y phase and b phase, resultant flux is this direction. At 60 degrees, now these two phases present, instead of this direction it is going this direction, you can see here. And next another phase it is going to this direction. Next another phase you are going to the and this direction. And next other phase we are going to this direction. Another phase you are going to take the this direction. Next phase is good this and it's going to this one. So that means simply it's a rotating in clockwise direction from 0 degrees to 360 degrees. The simple applications. Okay, I think you have some idea how this residual magnitude is 1.5 times. Always we are getting the 1.5 times of phi m, but the angle is changing from 1 degrees to another degrees. This magnitude is constant, but angle changing. So, this changing magnitude we are assuming is a rotating magnetic field, and that is maximum. Next angle is a maximum, next angle is the maximum. So, it seems to rotating. Okay. So, this is a thing you have to remember. You can see at 0 degrees this is the value. You can see this is the vertical, and this is this direction, and this direction, and this direction, this direction, and this direction, and this direction. So, it is changing continuously. That means this is changing. You can see it. At every instant is a y, b. It is a red and yellow. It is a blue and red, and blue and white. So, here similarly you are going to this. This is a very simple analysis. Now, hence what we have seen, we will conclude it. Hence, we conclude that the resultant flux is of constant value. Phi r is equal root 3 by 2 phi m. That is 3 by 2 phi m. That is a 1.5 times of phi m resultant flux. So, the resultant flux rotates around the stator at a synchronous speed given by ns is equal 120 f by p, where f is the frequency, in h p is the number of poles, and this graph is shown in the figure. Okay, you can see how it's changing its value when time passes. So I think so y phase is a green color, it is also rotating, but you can observe carefully. So if time passes, magnitude value, how the magnitude or phase magnitude changes from 0 to maximum to the negative. And B phase also change, you can see this, how this is a magnetic field, the fields are changing. At the same time, stator side, you can see the highlighting the colors, or phase, y phase, and that is a yellow phase actually. So it is changing at the, it is that blinking means at that condition the maximum value. In phasor diagram you can see it is how this is a value changing continuously. Okay, so this is one observation you might remember in synchronous motor. Now rotating magnetic field, same thing, this is a phasor diagram, vector diagram in diagrams. As before, the positive direction of the flux phases have been shown in figure. Okay, that is the whole thing. Now what is a mathematical proof? Mathematically we have calculated everything. So phi is equal to phi m into cos theta sin theta. This is the vectors we converted, that is the cos theta plus of j sin theta, unit vector. So multiplied with the sin omega. In previously phi r is phi 1 is equal to phi m sin theta. Here the unit vector taken cos theta plus j of sin theta into sin omega theta. Instead of theta we taken the omega theta. So phi 2 is equal, same similarly we taken the because 120 degrees, so phi 2 is taken the 240 degrees, and this one, and phi 3 is also we taken the 120 degrees, because each phase is a 120 degrees apart. So this is phi 1, phi 2, phi 3. So mathematically these equations we can add it. So we are going to get it similarly, same 3.3 by 2 phi m cos omega t plus j sin omega t, that is a unit vector, nothing but. So we are going to get that. So phi r is equal to resultant value of 1.5 times of phi m. Okay, so that means resultant flux is of constant magnitude and does not change with time. Magnitude is a constant, it does not change with time. But time passes, is a magnitude always same value, but it is an angle changing corresponding to the time. So summary, in this lesson we have learnt what is rotating magnetic field, how it is produced with a three-phase supply, mathematically proof for the production of rotating magnetic field also we have seen. I think you have idea about this, how the magnetic field is generated. Students, better to practice it, very easy. So we practice it at 0 degree angles, 60 degrees angles, then automatically similar methods, way of calculating remaining all angles. Then you can get the idea how the magnitude is constant, but it changing its angle. So these are the phasor diagrams, vector diagrams you have to remember, very easy. I think you have the some idea. Thank you for listening this class.